All right, so we're in chapter 15 today, right? Didn't you guys do 11 through 14 last time? Huh?
We did 13.
You did 11 through 13. That's right. Sorry. We've got to do 14 first. All right. Evaluation of algebraic expressions. All right. So, again, I'm really probably need to try to pick up the pace with this stuff because most of this stuff should be reviewed. Like the way Saxon kind of sets up their book is most of the beginning chapters, and when I say the beginning chapters, like most of the first half of their books are kind of review from our topics that were introduced last year. Some of the stuff may have been towards the end of the year, so if you didn't get all the way through the book in pre-algebra, then you may not have seen it. But hopefully this is going to be familiar to you. So if I have an equation, 3 different variables in it, x, m, p, and they tell us to find the value of this equation if x equals 4, m equals 5, and p equals 2. What am I going to do to solve that?
You'd multiply 4 times 5 times 2.
Yeah, so what did he do? He took all of those numerical values where we said x is equal to this, m is equal to this, and p is equal to this, and he plugged those in to this right here. So instead of x, we're going to write 4, right? Instead of m, we're going to write 5. And instead of p, we're going to write 2. Now, how did he know to multiply them together? Yeah?
Because they're next to each other.
Because they're next to each other. Yeah, so if you see variables next to one another, that implies multiplication, right? If it was addition, there would be a plus in between there. If there's nothing in between them, then you just assume multiplication, right? So we multiply all those together, and 4 times 5 is 20. 20 times 2 is 40, so the final answer for this would be 40, right? Does it matter which order we multiply in? No. Multiplication and addition, same way, right? You can do it in any order. 5 times 2 is 10, and then 10 times 4 will also give you 40. So just, when they're all together like that, you can multiply them in whichever way it's easier to do the math. All right, let's do another one. What if we had 4yz minus 5, and they tell us that y equals 2 and z equals 10?
Multiply 4, 2, and 10.
Multiply what?
Multiply all of them, or besides the 5, obviously.
Right, so
4,
not the
2,
5, right? So we're going to plug these in again. I would always do this step, guys. Take the time. Instead of just plugging it in and multiplying it in your head, write this line right here, right? There's where you get the partial credit. When you write that down, I see, okay, they get it. You just take the number that's associated with the variable and you plug it in, right? So I want to see this, and then if you make a math error, you're going to lose a point. 4 times 2 is 8. 8 times 10 is 80. So 80 minus 5. And then our final answer here is 75. I'm sorry, I didn't set a good example for you guys over here. I should have done that. Put a box around your answer so I'm not struggling trying to figure out what your answer was, right? And then finally, here's another one. Somebody else walk me through this one, but do it, putting in the step that I told you to put in to make sure you get partial credit. What's our first step always? Joni, you're already on the board. See if somebody who's not on the board maybe can walk me through this one. How would I tackle this one? Yep, Liam?
You would put -2 where y is, and put it in parentheses.
Put it in parentheses, I like that. See how he said to do that? Notice I always did that here. The parentheses will help you make sure you get the signs right, okay?
Minus -6.
-6 also in parentheses, right? So now we can remove the rest of the parentheses and say that that's the same as what? What would it be if I removed the parentheses?
It would
If I remove the parentheses from -2, what's that value going to be?
Wouldn't that be,
It would still just be
it would be the same.
-2, right? So that doesn't change. What about this guy? Minus a -6. What's that going to turn into? We've got two negatives side by side like that.
Oh, yeah, it would
It's going to be a positive, right?
positive.
So this is going to be +6. Now, doing the math for that, what's our final answer? Positive or -4?
Positive.
+4, right? We've got, this is the same, this right here is the same as 6 minus 2, right? So +4 would be the answer. Is anybody, did I lose anybody anywhere in that process? You know what I need to do that I haven't done? I remembered it earlier and then I forgot. I need to check your homework. So let's check your homework real quick. Okay, so let's do one more here just to make sure we get this concept down. A little bit different. -x minus -a plus b. X equals 2. A equals -4. B equals -6. Somebody walk me through this one. Who's brave enough? Liam was like, I'm going to take charge. I was trying to do an Irish accent that didn't come out at all. Or a Scottish one. Sounds like a very Scottish name or something like that. Liam. That's a hard accent for me to do. Who can do a good Scottish accent? Anybody here? Just awesome with that type of stuff. I can get an English one down all right, but I just can't do the Scottish one. I have to think about, what's the dragon cartoon?
How to Train Your Dragon.
How to Train Your Dragon. Yeah, I have to think about that, right? It's an occupational hazard. That's like the line that comes to mind to get me in the mood to speak in a Scottish accent. Who wants to try it? Somebody want to give this one a shot? All right, Allison?
You first do the parentheses.
All right, so parentheses here.
No, you like over to the side.
Over to the side. What's the very first thing I'm going to write down that I'm going to copy down from this problem?
-x.
First the negative, because we're going to plug in a value for the x. Right? So what am I plugging in for x?
Negative.
Huh?
Negative.
What is my value? What is my x value?
-2.
No, it's just a regular 2. Does it look like I've got a 2? Oh, you're talking about this negative here.
Yeah.
Okay, so this is what I'm going to recommend you do. What you were saying with the parentheses, do that first. Use your parentheses to plug it in everywhere, and then we'll worry about making sure we got the signs right. Okay? If you'll do this step first, that'll keep you from, this one's not that hard, but it's going to keep you from like weird ones when you get over here where you got parentheses inside parentheses and all that. It'll just keep you from making those errors. So my recommendation is to always use parentheses to start with. Okay? So copy down everything we've got until we hit another variable. So minus a negative, so what's the value for A?
4.
What am I putting in parentheses right here? What's my value for A?
4.
-4. You're taking care of the sign already, right? That's what you're doing. But I want you to put it in exactly like it is right here first. Because again, that's going to keep you from making a mistake with the signs. Do you see what I'm saying? Does that make sense? Do it like that first. See, I didn't change any of the signs that were in here. I've still got all of those signs in there. You guys see that? Here's that one. Here's the second one. Here's the third one. And here's the fourth one. All of those signs are in there. Yes?
Where did you get the fourth negative from, or the second negative for the 4?
This one right here?
Yes.
So this negative right here comes from the negative that's right
What
here.
about the negative on the outside? Parentheses right there.
There?
The third arrow.
This one?
Yes.
It came from right here.
Oh.
Because there's a negative sign right there, right in front of the A. See that? All right, so I'm copying down everything that's there, and wherever, I mean, we could do this. All right, we could write it like this. We're going to copy down the problem above with all the signs that were there above, but I leave all of my variables out. Right? And then I go in and I grab all of my variables that correspond to those. So x equals 2, so I'm going to put a 2 here. A equals -4, so I'm going to put a -4 here. B equals -6, so I'm going to put a -6 there. All right? I get it that some of you guys look at it and you go, oh, because I think, Allison, you were doing this. You're looking at the plus -6 and you're thinking already that's going to be -6. And you're looking at minus a -4 and you're thinking, well, that's going to be a +4, right? You're thinking minus a 2 here and that's going to be a -2. And so let's do that on your second step, because even you guys that are really quick with this, I can tell you from raising 3 boys that were really good at math, they would make sign mistakes because they didn't take this step right here. They just did it in their head and they wrote the numbers down and they ended up making a mistake. All right. So use the extra ink and do this step right here. Then go back and get your signs straightened out. Okay. The only other thing that you might want to do right here, since we got parentheses inside there, maybe you want to change these parentheses to square brackets just so that it's a little clearer since you've got parentheses inside. All right. So now, Allison, you're doing great. Now what's this going to be?
-2.
It's just going to be -2. Yep, you already gave me that, so I knew you had that down. All right. We're going to put our brackets here. What's this one going to become?
Like, add
Minus a -4 turns into a what?
+4.
+4, so we're just going to put a 1 there. And plus a -6 becomes a what?
Still a negative.
It's still a negative, so it stays negative. It's just going to be -6, right? So I've simplified it down that way now, gotten rid of my signs that were like directly in front of the numbers. What am I going to have to do next?
Work in the brackets.
I have to do the brackets first, right? The order of operations says knock these out before you do the outside arithmetic. So we're going to still say -2 minus, what does this turn into here? What's 4 minus 6?
-2.
-2, right? So I'll just keep it in brackets for now. Now, we can get rid of the brackets and make this, put the appropriate sign there. What's minus a negative going to turn into?
It would stay negative, right? Because it's in brackets, not parentheses.
It doesn't matter. Brackets and parentheses work exactly the same way. All right?
Okay.
What we need to recognize is we've got minus a negative, and so if we have minus a negative, that becomes
Positive.
a positive, right? So we're going to have -2 plus 2.
I was actually going to ask me.
You were going to see if you go the rest. I could tell that as soon as I called you out. Does everybody see that? Everybody see how we got that sign? All right, so what's -2 plus 2?
0.
0. So our final answer is 0. All right, and like a good student, I'm going to put a box around it. Yes.
This was the absolute most, I think it was one of the toughest things for me, is where they were adding the 2 negative numbers.
Uh-huh.
When exactly am I going to know to add 2 negative numbers? Because what it looks like is I don't know where to put parentheses around it, and if I do put parentheses, do I add or multiply? Or
Right.
do I use...
All right. So
That was absolutely horrific.
yeah, so that's when we're adding 2 negative numbers. When you have a negative number minus a positive number. If I were to have this, all right, if we had something like that, the first thing I want to do is when I have 2 signs that are next to one another, even if there's a parentheses in between them, I want to collapse those signs down. Okay, and a negative, the opposite of a negative is a positive, is the way to think about that. So this becomes -2 plus 2. So this one turns out to be 0. This is -2 minus 2. This one turns out to be -4. When you've got parentheses, the only time that you need to think about this parentheses being multiplication is when you have a number either directly next to the parentheses, touching the parentheses, all right? If you have this, that means 2 times -2. This equals 2 wasn't a good choice. Let me redo this whole thing with 3, just because 2 plus 2 and 2 times 2 are the same thing, okay? I want to make sure this is clear to you. So we're going to change this to 3, this to 3, this to 3, and we're going to change this to 3. And so -2 minus 3, that's going to be -5. We're adding 2 negative numbers together. We're adding -2 to -3, which gives us a -5. Here, the sign changes to be a +3, and so -2 plus a +3 gives us a positive 1. Instead of the 0 I've got there. But this time, we've got the number actually right next to the parentheses. See, we don't have the number right next to the parentheses here. We have a sign next to the parentheses. Do you see the difference between this and this? And so when we've got the number right next to the parentheses, that means multiplication, so this is negative 6. Now that's exactly the same if we had parentheses next to one another. So a number right next to a parentheses or a parentheses next to a parentheses, that means multiplication. So both of these are going to be 2 times negative 3, which is going to be negative 6. It's addition or subtraction whenever you've got a sign next to the parentheses. Okay? Does that make sense?
Yeah.
Yeah?
It kind of all just merges together.
Right,
It
I
does
get
make
that,
sense.
yeah, and you know, a lot of students definitely struggle with that. And so notice when we look at something like this here, we've got a sign and a bracket. Like I said, brackets, curly braces, parentheses, they all mean the same thing, right? We just use them. I could totally do this with parentheses. I could do it like that, and if I did it like that, then I would make these parentheses bigger just so I can tell that these parentheses go together and these go together, right? So we just switch to brackets so we can distinguish between, so we don't get confused and think, oh, this parentheses goes with this parentheses and it's the wrong one. So we switch and use brackets, but they mean the same thing. But notice in each of these cases here, none of this is multiplication because I don't have a number or a parentheses that's right next to this bracket. All right, that's what I have here. I have a number next to the parentheses. I have another parentheses next to the parentheses. For each of these, I've got a sign next to it. And so all that means addition or subtraction. Okay? And so when you have to use your order of operations and do the stuff inside these big parentheses first. And so we got a sign next to the parentheses, so we're gonna realize that that's addition and subtraction. And in this case here, we're just gonna combine those signs together. A negative and a negative collapses down to be a positive. And so that's why we made this a positive 4. And then a positive and a negative collapses down to a negative, so that's why we made this thing negative 6. Okay? Does that help?
So is it going to tell you when you should add parentheses? Like, if it wants a completely different answer, then...
Well, so what I'm telling you to do is when you have this scenario here, you remember I showed you at the very beginning, rewrite your problem with the parentheses in there before you plug in your number.
That makes sense.
Okay.
But I'm just asking, like, will they ever tell you to put in parentheses, like for the negative 2 minus 3 or something like that, instead of...
No, I mean, I might maybe would give you a problem where I said negative 2 minus x, solve this, and I said x equals negative 3.
Okay.
And so in that case, you would go negative 2 minus, and you'd put parentheses where the x is, and that's when you'd plug in the negative 3, and you'd get that.
Alrighty.
Okay, but yeah, otherwise they probably would just give you the problem like that and you'd have to solve it, all right? Okay, good. I appreciate you asking the question because if we don't kind of identify the areas where we're confused, we're not going to be able to, we just need to kind of keep going through these. Again, a lot of math is just working different problems and working it over and over and over again until finally it clicks and you go, okay, I've got it down, right? The more problems you do, the clearer it's going to become, all right? I know that none of us relish the idea of saying, I'm going to add homework to what's required. But sometimes we have to do more than what's required, right? If we're really going to get it down. I mean, just think about, are any of you guys athletes? What do you play? Oh, dance. So you dance, yeah.
And I run.
And what?
And I run.
And you what?
Run.
Oh, you run. Okay. So for dancing, for example, the instructor could show you the dance one time, and you could say, I think I kind of have that down, and so you go and you do the dance. But are you going to do it right? No, you're going to have to practice it over and over and over again. And some students are going to look at it, and they're going to just practice it a couple of times, and they're going to have it down. Other students are going to look at what the instructor did, and they're going to try to duplicate that dance, and they're going to have to spend hours getting that down. It's like that with everything in life, right? And math is no different. Some of you, because of the way your brain is wired, you're going to look at the problem, you're going to see the teacher do it one time on the board, and you're going to go, oh, I get that, and you're going to be fine. Others of you are going to go, I'm going to have to practice this over and over and over again until finally it just becomes second nature and I know it, right? And it's just like that with everything in life. And so if you want to get good at this, if you do a problem, so let's look at, for example, in lesson 14 here, right? For these types of problems, I always have you guys do the odd numbered problems, right? So if you look at the evaluate section on page 66, number 11, number 13, number 15, number 17, all of those problems are the type of problems that we're doing today. All right? Those are the only ones that I'm requiring you to do. But when you look at the book, you also see that number 10, 12, 14, 16, and 18 are the same types of problems. So if you do 11, 13, 15, and 17 and you go, that's still kind of fuzzy, go back and do 10, 12, 14, 16, and 18 until you get it down, right? Just practice it more. The more that you do, the better you're going to get at it, and the less confused you're going to be by things that are maybe confusing you right now. Okay? Sound good? You know what, you guys, I got to figure out what to do to make you guys smile. You guys just don't smile in here. I need more smiling, okay? You're bringing me down. I need some smiling. Bring your sunglasses if that helps you, right? Just pull the wheel and bring your sunglasses to class. Just kind of, just going to sit back with a little grin on my face. Whatever it takes, all right? I need more smiling, all right? Let's move on to surface area, unless you guys have any questions about this. Any other questions? All right. Surface area. What is that all about? When we talk about surface area, we think about like a cube. All right, so think about this. And if I have a cube is, if it's like a Rubik's Cube, all right? All of the sides have the same length. You guys agree? So all the sides have the same length. We'll just say, for example, that the length of this side is 2. So that means every side on here is 2. 2 here, 2 here, 2 here, 2 here, 2 here, here and here. Right? All the sides are 2. How many sides do we have on a cube? Think about that three-dimensional shape in your mind.
Is that 8 or 9?
No, not quite, huh?
6.
6 sides, right? So those of you that are do you have any Rubik's Cube people in here? My son's got like all these different. Are you a cube person? Do you have all kind of crazy like sizes and different? Yeah. Okay. So he's got a bunch of those kind of things, and then wacky things like pyramids and different shapes and all too. But so cube has 6 sides. So when we're talking about the surface area of a cube, we know how to find the area of a square. We should. What's the area of a square? Length times width. So since a square all has the same size, it's always going to be whatever the length is of one side squared. But you can totally think of it as length times width, which is 2 times 2. So it's going to, in this case, it's going to be 4. Right? Yes?
For length times width, could you also say like base times height?
Usually base times height, we reserve that for other figures, but as long as you understand this is the base and this is the height, then that's fine. Yep. All right. We usually use base and height for like trapezoids and triangles. That's typically, but that's just as long as you know what that applies to. So in the case of a cube, we've got 6 different faces, right, on each side of that cube that all have the same area. They're all going to have an area of 4 if the length of that is cube. And so in order to find the surface area, what we're going to do is we're going to add up the surface area. We're going to add up all of the areas of each of those faces. So we've got 6 of them, so we're going to say 4 plus 4 plus 4 plus 4 plus 4 plus 4. And let's actually give this a unit. We'll say that it's inches, right? So if it's inches, what would be my unit of this area here? What are area units always? Yep.
Whatever the unit is squared.
Squared. So they're always square units. So in this case, it would be square inches, right? And so that's exactly what's going to be our unit here, because for each of these we have inches squared, plus inches squared. We're not multiplying anything else together, so our final answer is still going to be inches squared. It's an area unit, so we expect it to be squared. It's surface area. 4 plus 4 plus 4 plus 4 plus 4 plus 4 is the same as 6 times 4. So our final answer for this guy would be 24. And so when we talk about surface area, that's what we're trying to do. We're taking each of the sides of whatever that three-dimensional figure is, and we're adding up the area of each of those sides. Okay, does that make sense to everybody? You see that? Yes, Mr. Walker, they said with a smile on their face.
Absolutely.
We see that. All right. Good. Well, let's talk about a figure that looks like this. What do we call that shape?
Cylinder?
That's a cylinder, right? So what about this shape? How do we find the surface area for that?
You want to find your circumference and then add it to whatever your length and width is.
Is it length times circumference?
It's some of what you're saying, you're on the right track. But let's think about this for a minute. So we've got a circle on the top and the bottom of our cylinder, right? We're going to give ours a radius of 3 centimeters, all right? And we're going to say that the height of this cylinder is going to be, it looks like it's about double that. So we'll say the height of our cylinder is 6 centimeters, okay? So when we're trying to find the area, we need to find the area, the surface area. We got to find the area of each of the surfaces on here. So we've got a circle on the top. You guys see that? That we can take the area of. We've got a circle of the same size on the bottom that we can take the area of. And then we've got all of this area here around the cylinder that we need to make sure we take the area of. Okay? I should have brought a roll of toilet paper to class, all right? The reason why is because if I were to cut this edge here and unroll this cylinder, what shape am I going to have? Does anybody know? Yep. It's just going to be a rectangle, right? Does everybody see that? Cooper's exactly right. And so, again, you can think about like unrolling a roll of paper towels or a toilet paper roll, right? If you unroll it and cut the squares off, what do you have? You have or cut wherever there's perforation on there. You end up with a rectangle, right? And so this rectangle, if you unroll this thing, it's going to have a height of 6 centimeters. But what's this length here going to be that I've labeled X?
It's going to be the circumference of the circle.
Exactly. Do you guys see that? The circumference of the circle is just the distance around here. So if I break this thing and unravel it, X is equal to 2 pi r, or in our case, 2 pi times 3, right? Or 6 pi is what that distance is there, 6 pi centimeters. Does everybody see that? So circumference does come into play, like you mentioned, Will, but we got to make sure that we include the area of the top two circles. So to find the surface area for this entire figure, we've got the area of this guy, which is pi r squared, the area of this guy, which is also pi r squared, and then the surface area of this area here, which is going to be, if the length of the top of my circle is 2 pi r, and the length of the other side is 6, then this area here is going to be 2 pi r times, in our case, 6. Because when you find the area of a rectangle, you take the length times the width. Length being 2 pi r and the width being 6. Yes? Yes, you may. So for surface area of this figure, that's what we're adding together. All of those things together. Now, since this length is exact, since these shapes on the top and the bottom are exactly the same, then we could say that the area of the top and bottom, we'll say the area of the circle. Let's just do the area of the circle first. Pi r squared. That's going to be pi times 3 centimeters squared. So that's going to be 9 pi centimeters squared. Did I lose anybody with the math on that? Did you guys follow that? I just squared by 3. I'm just leaving pi in here for now instead of trying to type in 3.14 on the calculator. We'll do that in a minute if we want to get a decimal answer. All right, that's the area of one circle. How many circles do we have? We have 2, right? So we're going to multiply that by 2 when we're calculating the surface area. And what's the area of our rectangle? Did we say? It's going to be 2 pi r times 6, right? So r is 3, so 2 pi r, 2 pi times 3 times 6. So that's going to be 6 times 6 is 36. So this is going to be 36 pi centimeters squared. They're all areas, so it's going to be centimeters squared. Did I lose anybody with the math for that? Everything's multiplied together, so we can multiply it in any order, right? I just had to multiply 2, 3, and 6 together to get the 36. And I'm leaving the pi in there as a variable at the moment. And so what's my total surface area? My total surface area is going to be 2 times the area of the circle, so 2 times 9 pi, plus the area of the rectangle if we unravel this guy, which is 36 pi. And so that gives me 18 pi plus 36 pi. If I add 18 and 36 together, I get 54. Is that right? 54 pi centimeters squared. Does everybody agree with that? Yep. Now this would be a totally acceptable answer. You could just leave the pi in there. Or you could plug in 3.14 in your calculator and you should get a number that's going to be around 160, maybe something like that. So you want to punch that in? What's 54 times 3.14?
169.56.
169.56. Like I said, we can always just round to one decimal place if I don't tell you what to round to. So either of those answers would be sufficient. All right? And you'll probably see both in the book. Sometimes they'll leave pi in there. Sometimes they'll give you both. The main thing I want to make sure that you guys grasp is how we had to take the area of each of those parts and then add them all up to get the surface area. Does that make sense to everybody? Now, if they use the term, they have some kind of crazy looking shape, but they call it a right solid or a right cylinder. Anytime they use this word right in there, which basically means that the angle from down here, the angle at the base where this guy meets is 90 degrees with that bottom surface. What that means for us is that the base, the top, this shape on the bottom is going to be exactly the same as the shape on the top. Okay, so we'll always be able to do this thing where we find the area of the top or the bottom and we multiply it by 2, and then we'll think about unhooking this thing and building the rectangle for the middle section, and then we'll add that to that. Okay. And so let me show you what I mean. We can have a shape that was a little bit different, but the process is exactly the same. So what if we had a shape that looked like this? On the bottom, on the top and the bottom. Let's make this a dotted line. So this is what my top and bottom looks like. This is 6. They tell us that these are all right angles, so we're dealing with a rectangle here. This is 6, this is 5, and they tell us that this is 3. Dimensions are in feet. Everything's in feet, and they tell us that it's a right solid that is 10 feet high. All right, so that means if we were to draw this thing out, I'm probably going to do a terrible job of this, so I'm going to go ahead and apologize to you guys now. It's going to look something like that, right? That's the way our figure looks. The same kind of thing. We've got a top and we've got a bottom down here that both have this shape because it's a right solid, so we know that the shape on the top and bottom are the same. And then the height is the same all the way across here. So this is 10 feet high. So if they ask us for the surface area, we're doing the exact same thing that we did for the cylinder, right? We're finding the area of this top, area 1, and then we're finding the area of the middle section, area 2, and our final surface area is basically going to be 2 times area 1 plus area 2. Is that clear to everybody? For these right solids, that'll always be the method that we find surface area. Two times the area of the top, or 2 times the area of the bottom, however you want to think about it, plus the area of the section around the middle. All right? So let's find area 1. I'm going to leave my equation over here for that. 2 times surface area equals 2 times area 1 plus area 2. All right, so what is area 1? Area 1 is this right here, the area of our base. How do I find the area of our base? Multiply what? Length times the width. But that's just for this portion of it, right? Just the rectangle portion. So length times width will give us the rectangle. So that's going to be 6 times 5. Or actually, the way it's drawn here, length is 5. So 5 times 6, really doesn't matter which order we do those in. Plus the area of this half circle. What's the area of our half circle going to be? What's the area of a full circle? Pi r squared. So pi times 3 squared, but it's half of a circle, so we're going to divide it by 2. Everybody cool with that? Yep. So that's going to be 5 times 6 is 30, plus 3 squared is 9, so we got 9 pi over 2. And so we could rewrite that as 30 plus 9 halves pi if we wanted to. Yes?
Is it okay to go ahead and multiply the 3 in your head and put it in there?
The 3.14?
No,
oh, sorry.
3 to the second power, the 9.
That?
Yes.
And just go directly to that?
Yes.
Sure.
Okay.
Yeah. Like I said, the only benefit of doing it like this is that if you multiply 3 in your head and for whatever reason you have a brain cramp and you say 6, I'm going to be, where did they get a 6 from? But if you do this, I'll know that you at least understood that this was the way to find it. You know what I'm saying? So that's where the benefit is of writing that down. It just helps me follow your train of thought, because all of us do crazy things like that sometimes, right? Where we know what 3 squared is, but we think the wrong number, right? So what are my units for this going to be?
Feet.
Feet
Square.
squared, because it's an area, right? So feet squared will be area 1. I'm just going to leave it like that for now. You don't have to. If this is bothering you and you want to go ahead and punch all that in your calculator, 3.14, and do all that and get a decimal version, that's fine, all right? Unless I say leave pi in your answers, then you're going to have to leave it like this, all right? Yes?
What's the difference between surface area and area?
Surface area is for 3-dimensional figures. Area is just a flat 2-dimensional figure, okay? Surface area, we've got to calculate individual areas and add them all up, areas at the outside. So that's area 1. What is area 2? Area 2 is going to be this thing here unfolded. So we've got this, we're going to have a rectangle when we unfold this thing, just like when we unrolled our paper towel or toilet paper roll. Let me do it over here. So we've got a rectangle, and the height of that rectangle is 10 feet according to this. What is this length going to be? What was our length last time when it was a circle? When it was a cylinder with a circle on the top and bottom, what was this length?
So is it going to be the perimeter of the...
It's going to be the perimeter, yeah. Last time it was the perimeter of the circle, which we call the circumference. This time it's the perimeter of this, right? And so what is the perimeter of this? It's all the distances around the outside there added up, right? So this value here is going to be this 5 plus this 6 plus this 5 plus whatever the distance is halfway around this circle. What's the distance halfway around that circle? around half a circle? What's the distance around the entire circle?
3.14.
Huh?
360.
That's the degrees. What's the distance? What's the length? What did we use for the length around this circle? We call it the circumference.
Oh, diameter.
Not the diameter.
Pi r squared,
Pi r squared is the area. What's the circumference?
2 pi r.
2 pi r, right? So this is going to be 2 pi r, so 2 pi times 3, that's our r, but it's only half a circle, so we have to divide it by 2. Does everybody see that? So that's going to be the length of that side. This is kind of, I need to move this out of the way because it's kind of getting in the way. I'm going to put that over here. Surface area equals 2 times a1 plus a2. All right, so we can work on a2 over here. So now I've got the length of this, so we can simplify that and say the length of that is 5 plus 6 is 11, plus 5 is 16. 16 plus, these 2's will cancel out, and so we just have 3 pi left for that value there. So that's the length of one side, and we know the length of the other side is 10 feet. So what's the area of this rectangle going to be? It's length times width, right? Will?
Restroom.
Yep. So the area is length times width. So the length is 16 plus 3 pi. The width is 10. And so when we multiply through, how do we multiply through like this? If we want to leave pi in there, how do I multiply 16 plus 3 pi times 10? What's the process called where we say, like if I have 2 times x plus y, how would I simplify that? Do you guys know?
Combine x and y and then multiply.
We can't combine x and y yet because they're not like terms. Like if it was x plus x, we could say that was 2x on the inside, but we don't have any way to combine x and y. So how can I simplify this? Do you guys know? Use distribution. Does that sound familiar at all? No? Where we multiply through by 2 and we multiply the 2 by both terms in here. So we say 2x plus 2y would be how we simplify that. Have you guys seen that? Some of you say yes, some of you say no.
I've
All right.
seen that, but I was sitting here thinking like where you have more than one x and more than one y, and then you combine them and then you do it.
Okay, gotcha. So yeah, that's distribution. I'm thinking that they're talking about distribution. Yeah, they talk about distribution in lesson 17. So we're getting a little bit ahead of ourselves. So what they're going to expect us to do in this case is do the 3.14. So we could combine this together. What's 16 plus 3 pi? Those of you with calculators, what's that going to be?
$25.42.
25.42. So that's what this is, 25.42. So we combine what's in parentheses first, then we multiply by the 10, so our final answer is 254.2. And what's our unit on that?
Feet.
Huh?
Feet.
Feet. It's an area unit, so it's feet squared, right? So that was that. Let's go ahead and we'll punch this in our calculator too. Let's see if we can get the same answer on this. 9 divided by 2 is what I'm punching in, because that's 9 halves, times pi, 3.14. I'm doing that first, then I'm adding my 30 to it. So I get a final answer of 44, I rounded it down to 0.1 feet squared. Did anybody not get that answer? Those of you that tried it, did you get the same thing I got? Okay, so now we're going to take those values and we're going to plug them in our final surface area equation. So 2 times 44.1 plus 254.2. And so 44.1 times 2, order of operations say I need to do that first, plus 254.2, and so I get 342.4 feet squared as my final answer. So that's what we're always going to do. We're going to take, for a right solid, we're going to find the area of the base or the area of the top. And then we're going to find the area around it. And the area around it will always open up into a rectangle. You just have to figure out what the length of this top part is of the rectangle. And the length of this top part will always be the perimeter around the base or around the top. And then we're going to take those values and we're going to multiply the area of the top times 2 and add them together.
Seems like a lot of work for one little shape.
It seems like a lot of work. I agree. And if you think about it as doing these different steps, it's going to be a lot to memorize. If you can just envision it in your head and you're like, I know how to find the area of different shapes. So that's really all we're doing. We're finding the area of different shapes. We're dealing with areas and perimeters. As long as you understand how to work with areas and perimeters, then just break the problem down into pieces. Because at the end of the day, you know what you're trying to find is you're just trying to find the area of all the different sides of this figure. And then adding all those guys up. Okay? Again, this is one of those things that the more you do, the better you're going to get at it, right? All right, let's go to chapter 16. And chapter 16 is more of the same thing that we've already done. I don't think we'll get into chapter 17 today. So we'll just do 13, 14, 14, 15, and 16. Let me just say this. For those of you that are really step-oriented, when we define the surface area, find the surface area of a right solid. This is a way that you could kind of tackle that problem, all right? Find the area of the top. So we'll call it A1. All right, find the area of the top. Yes? Yes. Find the area of the top. Find the area of the middle. By multiplying the height times the perimeter of the top. Okay, and we'll call it, find the area. I'm going to call this guy right here. We'll call this A2. I'm afraid if I put it at the end, you guys will think get confused about what I'm talking about there. So those are the two areas we have to find. We find the area of the top, and then find the area of the middle by multiplying the height of the figure times the perimeter of the top. So we're always going to have to calculate the perimeter and the area of the top section. And then finally, SA equals 2 times A1 plus A2. That's our final formula that we use to calculate the surface area. So when you break it down like that, it's really not, the overall process is really kind of a simple process, right? You just have to, it can be involved depending on how complicated this top shape is. It can take you a bit to figure that out. If it's got squares and triangles and half circles and all this kind of stuff on it. So let's do some more complicated evaluations. This will be good. This is some of that practice stuff that you were talking about that gets kind of confusing. So they're going to give us an opportunity to use brackets and parentheses and all this sort of stuff and figure out when we're multiplying, when are we subtracting and adding.
This is lesson 17?
This is lesson 16, huh? So,
Oh, okay.
yep, lesson 16. So we're given this, and we're told that P equals -2, and that A equals -4. And they want us to simplify this guy. Find out what the final answer would be. Is everybody back? Then let's go to the bathroom. No, we are missing someone. Did he write down those steps? I don't know if he did. I better leave this on the board just in case. Let's find SA. Alright, so we'll just work over here on this piece. What's my first step going to always be? Because I don't want to mess my signs up, so I'm going to be really careful about doing what first. Rewriting it, just putting parentheses where those variables are and plugging my number in, right? So I'm going to say negative, like this, minus. I've got a variable right here, so I'm going to put some parentheses. I'm going to make these parentheses bigger. Put some small parentheses in there, minus another variable. So we've got some parentheses there for that. And here's my other parentheses, and I put my square bracket on the outside. So do you guys see I've just rewritten all of this down? I didn't mean to put my A there. We're going to plug in the values for those guys. So everywhere I've got a variable, I've put my parentheses in there. So now I'm just going to take my values and plug them in. A is equal to -4, P is equal to -2, A is equal to -4. That's my first step. You do that step and you've already got some partial credit on the problem, because I understand that you get the fact that you're just plugging in the value for those variables. Cohen, do I need to leave this up here? Okay. What am I going to do first now? Parentheses. I got a bunch of parentheses. Yeah?
The parentheses inside
The
parentheses.
parentheses, so the innermost parentheses are always the ones we need to start with, right? Whether it's brackets, there's curly braces, or parentheses, whichever one's the innermost one, that's what we need to focus on. So I'm gonna bring it out here just so we can see everything a little bit better. Negative, parentheses, -4, big parentheses, little parentheses, -2, minus, -4, big parentheses, and then square brackets. All right, there. So we're going to work inside here. We're going to try to get rid of those little parentheses first. So negative, I'm not even going to touch any of this stuff. I'm not even going to think about it yet because I'm not working with that yet. I'm just going to do what's inside these parentheses here. What does the -2 become? Does it stay a -2 or does it become a +2? Stays a negative because there's no sign in front of it that's going to change it, right? So it's still -2. What about this guy? Minus a negative number. It becomes a positive, right? So this becomes +4. So I'm still working with my inner parentheses. So I'm going to write everything down again. And inside these parentheses here, what's -2 plus 4? 2. Just 2, right? All right, make sure you guys are tracking with me. So now I'm done with the stuff that was inside my big parentheses, right? What am I going to do next? You actually have some options here. What are you going to do
You're going to
next?
start with the negatives and see what you can turn that 4 into, which it
So-
would be -4.
These two negatives?
All three of them.
All three. Can I touch this negative yet?
Well, you start with those two.
I would
and then-
start with these two,
Yeah.
yeah. I would start with these two because they're all inside the brackets, right? So let's deal with inside the brackets next. So remember, these parentheses here just mean we're multiplying these guys together. So we have a negative and a negative here, so that becomes a positive. So we could rewrite this as +4 times +2. And so now we've got -4 times 2, which is 8. And then when I take the negative of 8, I end up with -8. So it's overwhelming when you just look at it at first, but if you'll just take it in little pieces like that, work your way through the parentheses little by little, you end up getting I wrote it down wrong. So this is what ours is. If you look at the one in the book, they actually had another A in the front here. So after we got the 8, we were going to have to multiply it by -4. So the final answer is 32 for the one in the book. But I didn't write that one down. All right, let's try one more. And I'll try to make sure I write this whole thing down correctly. AX, brackets, negative A, parentheses, A minus X. And they tell us that A equals -2. And X equals -6. Now, because we are going to use parentheses to represent the ones that we put inside there, one thing you could do to just kind of maybe make it less confusing for you is you could take everything that's a square bracket and change it to a curly brace, and everything that's a parentheses in the original problem, change it to a square bracket. And that way, when we put our parentheses in there, it's not going to be as confusing looking. All right? So now we're going to do the first step that we always do. We're going to put parentheses everywhere we have our variable. And we're going to go ahead and fill them in this time as we do that. So the A is -2, so we're going to write that like that. Our X is -6, we're going to write that like that. Here's our curly brace. We've got a negative A is -2, so we put that in parentheses. Stop me at any point if you're like, wait a minute, why did you do that? Make sure that you guys are tracking with me. Square bracket, A in parentheses, -2, minus X in parentheses, -6. Close my square brackets, and close my curly braces.
How do you get the -2 and -6 at the front?
Right here,
No, the other one.
this one.
Yeah.
So this is A times X, because variables right
I
beside
thought it was
one.
a 9. Never
Oh,
mind.
no, yeah. The A's kind of stink for that reason, because students always get confused, think my A's are 9s. Doesn't matter how short I try to make it. That one's actually pretty good. This one was a little longer. That one's a little long. Yeah, there we go. All right, so everybody following that? Does that make sense? All right. Again, partial credit already, because you wrote all that down, right? And you showed me that you knew where everything went, and you got the signs correctly, where the parentheses are. So I already see that you at least understood how to plug it in correctly. But you definitely have to, in this case here, you're definitely going to have to start combining to get full credit for the problem. And where do we start? We always start with our innermost brackets or parentheses or whatever, right? And so in this case here, where would our innermost ones be?
-2 minus -6.
What's that?
-2 minus -6.
Yeah, this one right here, that's inside our square brackets, right? So we're gonna keep all this stuff like it is. And we're just gonna work with what's inside my square brackets here. What is -2 minus -6? Does everybody see that's the same as -2 plus 6? All right, so we're gonna try to skip a step this time, kind of help you. Little by little, we wrote a little more down last time. This time we're just going to skip that step. -2 plus 6 is the same as what? Yeah.
4.
That's going to be +4, right? -2 plus a +6 is +4. So we're going to write down a 4 there. Now what are we going to do next?
The other stuff in the brackets.
In this here.
Or parentheses.
Now this is what I want you guys to understand. If I see this negative out front here, I want to make sure you guys are clear. I can think of that as a -1. Just multiplying everything through by that -1. Right? Anytime you have 1, what's the final answer for that? Yeah?
+2.
That's a +2. And that's because -1 times -2 equals +2. Right? You can always think about it like that. So the reason I said that is because really we're just multiplying through all these numbers together in our curly braces. And we're just saying this negative times this -2 becomes a +2. And a +2 times a 4 is what? What are all these multiplied together going to be?
It's going to be a positive.
Positive, and what's my final number?
8.
Huh?
8.
8, right? So now we've got -2 times -6, and in our curly braces here, that all reduces down to 8. So this is really our last step, because all of these numbers are what? to one another. They're all gonna be added, subtracted, divided, multiplied, what? They're all multiplied together. So negative 2 times negative 6 is
Positive 6, or positive 12.
positive 12, and positive 12 times positive 8 is
96.
96. Excellent. Somebody that knows the 12 times tables. Good. Yes.
Please, Mr.
Yes, go for it. Which I'm actually letting you guys go. Isn't it 11:10 that we stop?
Yeah.
Yeah. So that's my final one. So just make sure you practice extra problems if it's confusing to you. And remember, next week I need to see your work, and I need to see that's graded in your homework, right? If you're going to get full credit on that. All right. Don't forget to take your tests. And you guys have a great rest of your week. Yes.
I did my homework. I just